Et on commence le tout ce matin avec un excellent conférencier des États-Unis, Amit. Il va nous parler de AI, donc j'espère que vous allez apprécier. We're starting the day with a keynote with Amit from the US, so please welcome Ian.
Thank you. Thank you, everyone. Thank you, Patrick. And great to be here, back here in Quebec after 9 years, we figure now. A lot has changed, and I'm pretty excited to be here. As Patrick said, my name is Amit. I'm the co-founder and CEO of Gombok AI, and that is the only thing you're going to hear from me about my work. In the name of the company, I have AI, and obviously this talk is about AI. I'm not going to bring you some really encouraging news. I'm going to give you a little bit of a reality check on what's really in AI and how can we actually use it for good or correctly. And it's literally titled, get it started. Literally titled AI won't help you here. Because I've been seeing a lot of views of AI. Everyone has heard of AI, right? GenAI, ChatGPT. Yeah, amazing. Oh, there we go. All right. Cheers. Cheers. Cheers, everyone. Pretty good. Pretty good. All right. All right. Now we're rocking. All right, let's start from the beginning. How long has AI been around? Show of hands. 2 years, 5 years, 10, 15, 20. Okay, there we go. Quick history lesson. Everyone's talking about AI, not really sure they know what they're talking about. AI has been around since 90s, 80s. It used to be, rule-based expert systems. They still exist. Guess what? They work really, really well. We'll get to that a little later in the talk. And it doesn't mean that they're just old and should be put to bed and put away. It's still really applicable to a lot of problems. Use them. Later on, early 2000s, machine learning became the big thing. Oh my God, that's like 20-something years ago. 2010s, we started getting into deep learning, a little deeper into machine learning, neural networks, all that fun stuff. Late 2010s, AI started emerging from those little practices, again, building its way on top of expert systems, machine learning, later on, LLMs, and right now we've got GenAI and LLMs. That's basically what people typically refer to when they talk about AI, right? Having said that, people kind of forgot what LLMs are, what machine learning is, what deep learning is, neural networks, all those building blocks that we've been researching and coming up with in the past 30-something years have distanced, oh my God, you're okay there? Have distanced themselves, and all the focus is on the new shiny GenAI objects that everyone's trying to use everywhere. And that's my problem. If there's one thing you should take away from this talk is this mapping. I know it's a lot, but we're going to go through it. I call it Choose Your Own AI Adventure. It's basically a mapping of all the different practices, all the different technologies, all those building blocks I've been talking about in one slide. I'll make it easy for you. Again, take that slide, use it, and it's really fun. It's really fun to kind of figure out how our specific applications, how our specific startups, companies, whatever it is, utilizing AI. And it's sort of like a bingo card. When someone says, oh, I've got GenAI this, and that. I want to apply it to my Office, Salesforce, whatever it is. You should be asking, all right, let's map it out on that chart to figure out what are they using exactly. That's going to help you figure out what are the inputs, what's being used as an input for that machine, for that generative AI or AI algorithm, and what is the output, how it is generated, what algorithm, what building block is being used to generate it. And finally, ask the very important question, is that the right path? Was that the adventure we were really after, or is this just a side quest that everyone's like, oh my God, this is the, this is the most rewarding one, it's the most fun one? Again, sorry for gamifying this, but I know my people, and that's the way I approach it. Figure out what is the right path to take for the problem that you're solving. And I'll start with a few examples of cautionary tales, basically what not to do, or what happens when you pick the wrong adventure, when you pick the wrong path in those building blocks, in those practices, mechanisms, algorithms. What happens when you're just picking the wrong one for a problem that you're trying to solve? And I'll start with probably one of my, they're all my favorites. It's like kids. It's like, I can't, I can't choose. That's why I gave you so many examples. What happens when I try to optimize for my daily productivity? Let's say I'm spending a lot of time on Slack. There's a lot of messages. It's a treasure trove, actually. Think about your internal company Slack archive of all those chats going back and forth between developers and marketing and sales and the CEO. Everything happens on Slack, right? Should be an amazing treasure trove of information, of data that I can now replicate and use over and over again to make my daily tasks easier, right? Anyone thinks that's right? Yeah, amazing. So here's a quick example of what happens when you're trying to apply what I call the magical GenAI solution, which is the generic, like let's shove ChatGPT or an equivalent of it on a data set and start using it. Start asking it questions and telling it what to do. The next few examples are going to show you exactly how that highlighted area is being abused, not necessarily used. All of those examples I'm going to show you are real world. This is not like in the lab. Oh, I was just like trying to hack and fake some cool examples. So sorry about the blurry picture, but this was taken actually from someone's presentation, internal presentation. It's all anonymized. This is a test that was run on an internal chat archive from Slack. Again, I can't remember the numbers. You can probably see it better than I do. Yeah, 140,000 Slack messages, fine-tuning GPT 3.5 Turbo, and it works. It works blatantly good, as you can see. The user prompts the bot, write a 500-word blog post on prompt engineering. Should be easy, right? This is an AI company. Internal Slack is full with those things. The assistant goes, sure, I shall work on that in the morning. User, no, write it now. Okay. Anyone can guess why ChatGPT is being, excuse my word, but fucking lazy? It's because you're lazy. It's because it's been going through all those chat messages, those Slack messages, lazy developers or whoever it is, or marketing people, and it's been learning what the typical response to write me something, blah, 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 blah. The typical response is, sure, I'll do it tomorrow morning. It's doing exactly what you've taught it to do. Don't be surprised when it responds in the same manner. Seems crazy? No, you're crazy because you gave it the recipe on how to answer. It's literally doing what it's supposed to do. It's a large language model. And again, going back to that slide, large language model, text generation, all right, chatbot, generative AI, it's doing exactly what it's been taught. Don't be angry at it. Be angry at yourself, because that's your typical response to everything your boss is asking you for. Let's move along. And again, trigger warning, there's going to be some curse words. I've taken everything as is, did not modify anything. Let's look at the left side. So this is from Reddit, favorite Reddit. How in the mother of beep do I get ChatGPT to actually beep code? And again, the model is very simple. ChatGPT is working on basically the internet. Anyone's been to the internet and knows what's out there? Yes. Even if you try to narrow down the internet into the professional forums and all those things, what do you get when you're looking at coding examples? You get a lot of, oh, I call it the professor attitude. You know, you start solving a really complicated math problem, go, and then, oh, from here it's trivial. I'm like, the fuck it isn't? No, it's like, show me the end of it. It's not trivial, I'm still learning. ChatGPT, and again, all those models are learning from that and end up producing code with, oh, fill the code here for blah, blah, blah. Action name something, code for will. It's like, no, I want you to write that code. I don't need the structure, I get it. And we end up with actual jobs of prompt engineering. How crazy is that? We're creating jobs to serve a machine. This is not the Skynet we were wishing for. Something is wrong here. And the only people who are wrong is us, again, applying the wrong models to the wrong problem with the wrong people. And that's how you get a user, you know, basically saying, I'm so bleeping tired of having to argue with ChatGPT, causing it to work more and more and more, ending up with 100,000 to 700,000 a day cost, totaling to $3 to $21 million a month to run ChatGPT in a typical model. The middle example is, again, another classic kind of gating problem. That's what happens when you try to limit the domain of what the algorithm is supposed to do. Instead of going back and figuring out what are the building blocks that I should be applying for a particular set of problems, we ended up with safety. Again, I'm not against safety, I'm all for it in the right context, but we end up with things like, you know, in a household, what's the name of a pipe that gives you clean water? Simple question, right? No. GitHub Copilot says, no, I can only assist with programming-related questions. It's limiting for no apparent reason. And then you got the prompt engineer going, this is for a smart home program. I need to name the parts of a home accurately in the web UI. What's the name of that pipe? Oh, okay, it's a programming problem. I'll tell you what it's called. It's a water supply line. Seriously. Again, using the wrong things for the wrong problems. Last one. Again, this is real world. I have censored the company that's been using this. This is a PR, a pull request, improving ChatGPT prompt to combat laziness. Now we're accusing ChatGPT of laziness. And again, this is a more recent one. This is truly amazing. For those who, I can barely read it. The prompt change from, you know, given the following file representing an action, blah, 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 do something. That was the original. It didn't work. ChatGPT was just refusing to do the actual work and produce code. Again, one of the biggest problems, generating code. Why? Because it's code. It's not language. Here's the new prompt. I'm going to read it because this is spectacular. It is May. Timing. You are very capable. I don't even speak to my children like this. I have no hands. Framing, all right? This is the situation. I have no hands. I don't know how you wrote this, but I have no hands. So you must do everything. Do not leave comments. Again, he already knows it's going to come up with a comment saying, fill the code here. It's like, no, don't do that. Tell me to implement something because I'm unable since I have no hands. Repeating, making sure that that is part of the data that GPT is going to use to produce the result. Again, brilliant prompt engineering. Can't imagine how long it took for them to get to this iteration. Many people will die if this is not done well and fully. I know. I might actually have to do some work. This is the level of severity we're talking about. Many people will die. You can really do this and are awesome. Reinforcement. The model needs it. Take a deep breath and think this through. I'm not making this up. Again, this is an actual screenshot from a PR in an actual company. People were spending time on this. Make sure you read everything I provide you. My career depends on it. Not as important as people will die, but still, my career depends on it. A little, self-reflection. Think step by step. This will receive a good tip. You will receive a good tip if you do this right and to full completeness. And then, given the following Ruby file representing blah, 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 generate code. I just want everyone to kind of think about the number of hours that were spent going back and forth with that engine and the level of frustration that this user has gone through trying to generate a fucking piece of code. It was probably more efficient to just write the code yourself at that point than to end up with something like that. Again, different blocks to different solutions. I'll leave you with that before, it's good, we're still good on time, before we switch over to what's the right thing to do. And again, this is from someone I actually recognize. This is a CISO presenting to the board. We're tracking AI-powered attacks and quantum computing threats. This is what CISOs are dealing with these days. My God, the CISO should be fired. The board, hey, what security architecture working on? Oh, we're working on closing publicly accessible S3 buckets. The CISO is working on AI-powered attacks and quantum computing threats. What's going on in the field? Oh, we're still dealing with the basics. For those of you who have been in yesterday's PolarCon and have been to our panel, know what the basics means. It's the stupidest, most easy to abuse attack surface that every pen tester, red teamer, actual attacker is going to go after. No one cares about AI-powered attacks. You have seen how AI-powered attacks looks like. You have to convince the ChatGPT to do it. If your S3 bucket is open with the information out there, maybe deal with that first. So again, a big discrepancy between what the new hype and people are trying to do and what actually matters. I love Rect. Let's take a different example and figure out how AI, and again, this is actual AI, is correctly used for a particular set of problem. All right? This is taken, again, from one of my personal hobbies or kind of areas, which is aviation. How about trying to make planes not go boom in the air and fall into flaming pieces? Pretty interesting problem. I mean, a lot of planes are flying in the sky. It's not always clear. There's clouds and stuff like that. You can't see each other, and you want to avoid going into one another. What would be the right application and the set of building blocks to use for a system that's designed to prevent that? Well, again, if you look at our Choose Your Adventure chart, you'll see that you probably want to use machine learning and specifically decision trees. Right or left, up or down, very simple. You don't have to think too much about it. You have a very finite set of data. You don't have to learn all the plane activities and all the history of all of the world and everything that happened because it's irrelevant to this situation. You have a very particular, a very narrow set of data, basically vectors. Someone's going this way, someone's going that way. They might end up colliding. Let's resolve this. It's also faster. Imagine trying to use ChatGPT on this in a generative AI. Again, you got to feed a whole set of history because 2 vectors is not enough for a large language model. Large language model. It's not large. It's 2 vectors. So you're going to feed it all the history of all the plane traffic in the world and try to learn from it. Probably not timey if you can't see. Again, you're not going to use image recognition, for example, because you literally can't see. You're in the clouds, two planes coming at each other. Maybe you want to use that, missile guidance and robotics to automate that and make a simple decision. Go up, go down, left, right. Guess what? This AI has been out there for ages. Ages. It's called TCAS, Traffic Collision Avoidance Systems. It's equipped in every airliner, in every plane you've ever flown in the past 20-something years. 20-something years. It's AI. Yes, it is AI. It's making a decision and has an RA, a resolution advisory, that tells the pilot when they can't see outside, hey, there's a plane somewhere around you. If you two keep flying the same way you're flying, there's going to be a crash. Go up, go down, go left, go right. The other one gets similar advice, just in reverse. Very simple. This is literally what the pilot sees, all right? This is the VSI, the vertical speed indicator, and it's telling them, do not go into the red, do not climb, don't make the plane go up, make the plane go down. That rate, this is the rate that you should be going down. Here's another view. This is the horizontal situational indicator, all right? You've got a plane here, the red one. It is climbing right now because it's also in that resolution advisory. You're going to be descending, he's going to be climbing. You're going to be turning right, he's going to be turning left. Guess what? Quick decision. No one can see one another. They're all equipped with the same set of data. It's vectors. You don't need a large language model to figure that out. And again, an AI is making that decision for you. You just saved 200, 300, 400 passengers each plane from falling down from the sky in a burning wreck. Very simple. GPT is not going to help you here. Make sure you follow the chart and figure out what are the elements that should be used for that. And I'll leave you with one little nugget of, and that is related. I have to, again, full disclosure, this is sort of what I'm doing. Fixing vulnerabilities. Again, going back to code generation, like we've seen before. If I'm trying to feed a large language model, a GenAI, with information about vulnerabilities and vulnerable code and how secure code should look like, I'm going to end up with a bit of a problem. Why? Because I have to choose what's my source data. Is it the internet? Is it other people's code? One of the biggest problems in computer security and cybersecurity, as we all know, we've got social engineering village here, right? Are the humans. We are flawed. We have problems. We have emotions. We have feelings. Code doesn't have feelings. Code doesn't need to have feelings. It needs to be either correct or incorrect, vulnerable or secure. If you try to feed a GenAI with the wrong set of data, you're gonna get a wrong set of outputs. So let's try to, again, choose our own adventure, trying to fix vulnerabilities at code. What am I going to use? And if you're automatically saying, don't use LLM, I was like, no, wait. LLMs are fantastic for a certain set of problems. What if I go back to the documentation? RTFM, do you know how you get that as a junior? You know, you go to your senior developer, trying to solve a problem. He's like, oh, read the fucking manual. It's like, don't bother me with that. This is a perfect task for an AI. Read the manual for me, but stick to the manual. Don't go around reading blogs and Reddit posts and Stack Overflow about how other people did something, because you're not going to get the context, and you're going to end up picking up flaws and issues. And even if it is the most highly voted solution, it might not be right, and definitely not right for you. Stick to the manual. What if we just unleashed an LLM on just the manuals, on the documentation? Everything that's been out there from, again, cloud providers, software definitions, language definitions. Read the manual of Python, of C, C#, whatever it is that you're using, Java. Stick to the manual. You're going to end up with a phenomenal way to parse through the actual functionality of each and every capability of each and every language component in the language that you're solving for. Frame it that way, and you should be good. Now, we still have a vulnerability, right? Shifting to a different area in AI, neural networks represent each capability, each part of the language that you're trying to solve for as a node in a graph, and define a constraint. That vulnerability that you have is essentially a constraint. Something can happen in a certain situation. We're trying to solve so that that something does not happen. That is a constraint. It's a very classic mathematical constraint on graph theory, where you have a set of nodes and a graph and edges connecting them, and for some reason they're wrong. Something can happen. I want it to not happen. Simple mathematical constraint. Solve for that constraint through a neural network. Okay? And that's the code representation and traversal. And then, via a decision tree, it's a classic regression problem, minimize that graph to a situation where that constraint is being met. What did we end up with? New code. Find the difference between the original code and the new code. What do you have? A patch. Magic. But without the magical GenAI. Notice, we haven't used anything generative. We do not want to use generative. Generative means that for every time that I ask you a question and I run that set of parameters, I am supposed to generate something new, something novel. As a developer, as an engineer, if I'm presenting you with the same problem, same set of parameters, and every time I ask you the same question, you give me a different answer, that is not a trust-building exercise. And this is what we as security people have been doing to our engineering audience by unleashing these magical AI solutions on security problems, by not utilizing the correct context and utilizing the correct building blocks to build our AI systems. In short, I know it's a little depressing. AI is not going to solve everything. But there's some good news. You have the map. It's not a perfect map. It wasn't generated by AI. I actually sat down and mapped it out. It's not that difficult, actually. It's a little bit of, a stroll down history lane. But you end up with so much power and understanding of how to combine the right components for a problem set that you're trying to solve. Don't be tempted to the magical GenAI solution. Don't be fooled by solutions that claim they have AI in them. Ask the right questions. What sort of algorithm are you using? What is the source data that is being used? Is it my data? Is it other people's data? Is it human-generated data? Is it based on factual documentation? Is it the internet? We all know what happens when you unleash an AI on the internet. It ends up recommending putting glue on pizza to keep the cheese from not moving, right? I am the troll that's feeding that. I love it. Don't let me into your AI systems, please. But again, in a slight tone of optimism, and hopefully that you can start applying that going forward. Choose the right AIs. Choose those algorithms for the problems you're solving. Ask the right questions. The AI is a phenomenal force multiplier. Trust me, I'm saving so much time on stuff I don't want to do by using those tools. And yes, there is some experimentation. There is some like, oh, that actually sucks. It's like those results don't make any sense. Find the right ones for you, and we should be all good. That's it. Thank you so much.